Morning guys, today we're going to take a look at page 4 of the Unit 4 Classwork packet. The page number seems to have gotten cut off, so just look for the big word transversal at the very top. Now what's a transversal, you might ask? Well, a transversal is a line that intersects, or you can say cuts through, at least two other lines. So take a look at this diagram here, which is reproduced for you in your Classwork packet. In this diagram, do you guys notice how line T cuts through these other two lines? That means that line T would be considered to be a transversal, okay? Now, the important thing about transversals is that when we have them, they create special angle relationships. They create special angle types that later on in the course we're going to use in order to be able to solve problems. Let's go through those step by step. The first angle type that we're going to look at is called corresponding angles. Now, what does corresponding mean? Corresponding means that they're in the same relative position. Let me try to clarify that for you, okay? Do you guys notice how angle 1 is on the left side of the transversal, and it happens to be above this line? The only other angle in the diagram that fulfills those same criteria, as in it's on the left, but also above a line, is angle 5. So we would say that 1 and 5 are corresponding. The same holds for 2 and 6. The reason is they're both on the right and they're both above. Similarly, we could say that 4 and 8 are both on the left and they're below, and 3 and 7 are both on the right and they're below. Okay, so that's what we mean by same relative position. Now let's talk about alternate interior. The word alternate means kind of like opposite, right? And interior means in between the two lines. So which angles are in between these two lines but on opposite sides? Well, that would be 4 and 6 and 3 and 5. So there are fewer pair of alternate interior angles, but there still are two pair in a standard diagram. Alternate exterior, instead of the angles being in between the two lines, they're going to be outside. And the alternate part of it means that they're on opposite sides. So let's take a look at the diagram. 1 and 7 are on opposite sides. This is on the left, this is on the right, and they're exterior, meaning that they're outside the two lines. Similarly, 2 and 8 are on opposite sides of the transversal, and they're outside. So we would say that 2 and 8 are alternate exterior angles as well. Okay? All right, next up, consecutive interior angles. Okay? Consecutive, or also known as same side interior angles. Now, consecutive means one right after the other, right? Kind of like in a line. And interior means inside. So in this case, the two that are right, one right after the other, and inside would be 3 and 6 and 4 and 5. It wouldn't be 4 and 3 and 5 and 6 because those are actually a different angle type that's called a linear pair. Okay, so yeah, just trust me on this one, okay? Consecutive means one right after the other, right? So they're kind of like one right after the other here, but they are interior. I want you guys to cross out consecutive exterior because we don't even need to know that. Like, that's not even a theorem on the EOC. So cross it out, put a big frowny face, do whatever you need to do, but no, just no. Okay? Now, with that being said, let's take a look at an example, okay? Let's take a look at an example of what this could look like on a test, okay? And we're going to take a look at example number 4. Let's take a look at example number 4. All right. So this one is kind of like this mutated tic-tac-toe board, right? And that creates its own set of problems for us, which we'll talk about in a minute. All right. But the trick with these problems is to break them down such that they are only dealing with one transversal at a time. And I will definitely show what the heck I'm talking about. Okay? 5, 6, 7, 8. Presumably, it would be 13, 14, 15, 16. Let me make sure I label these right. Okay. Yes, I did. Okay, cool. So let's take a look at these classifications, okay? This is example 4. Let's take a look at angles 5 and 13. Well, 5 and 13, okay, so we're talking about this transversal here. They're both on the left side and they're both above. So 5 and 13 would be considered to be corresponding. 7 and 14, okay, let's go. 7 and 14, so opposite sides, but they're in between the lines. So those would be alternate interior. Now let's take a look at 3 and 6. Okay, so now we actually have to crane our necks. What I would want you to do without hurting yourselves is look at this diagram sideways. So 3 and 6, if we use this as a transversal, they're on opposite sides and they're both outside. Like you see how this one's like outside that line and this one's outside that one? So we would classify them as alternate exterior. What about 9 and 14? Okay, 9 and 14, well, there's actually no relationship, right? Because they're on the same side, but they're exterior. We said we're not going to worry about that as a type, right? So you can just write like a happy face or frowny face or whatever the case might be, but no relationship. Next up, 4 and 7. Let's take a look. Okay, 4 and 7. So if we crane our necks once again and look at it sideways, we see that these two are on the same side of the transversal and they're interior. So what that means, because they're both in between these two lines and they're both on the left, we can call them same side interior, also known as consecutive interior. Now let's look at 2 and 10. Okay, 2 and 10. Right side and both above. So that means that they are corresponding. 8 and 14, well, they're both in between these two lines, right? And they're on the same side, so we would say those are same side interior, also known as consecutive interior. Now let's look at 6 and 11. Okay, 6 and 11, oh my god, what the heck is that? Guys, they're different transversals. This one's with this transversal, this one's with this transversal. So no relationship, big frowny face. 4 and 13, let's take a look. 4 and 13, same problem. This is with this transversal and this is with this one, so no relationship. And last but not least, 4 and 9, this time there is a relationship. They're both in between these two lines and they're on opposite sides, right? So we would call those alternate interior angles. The biggest piece of advice that I can give you guys is only look at one transversal at a time. If they give you this monstrous tic-tac-toe, mutated tic-tac-toe kind of board, ignore the other transversals, right? Only look at one at a time, decompose the problem into smaller, more manageable bits.